Right, this is the last section that we have for chapter 5, and actually a new way to prove statements. This is called an indirect proof. Up to now, the proofs that we've been doing have been direct proofs. You take facts that you know and arrange them in a way that gets you to the desired result. So it's a direct path to your thing you're trying to prove. The indirect proof is we're going to assume that the opposite is true and then show that that assumption can't possibly be correct. So we're going to basically prove that the opposite of what we're trying to show can't be true. So I've got some examples because it's hard to conceptualize without examples. So let's say we've got a triangle. So this is given. So the given information is what we know to be true. We know that this triangle ABC is a right triangle and angle B is our right angle. And we want to prove that ABC does not have an obtuse angle. So if that's what we're trying to prove, what I want to do is show that the opposite of this can't possibly be true. So the opposite of this would be to assume that it does have an obtuse angle. So in my proof, I would say, let's say the measure of angle A. Okay, it doesn't matter which angle we pick, A or C. We're just going to assume that one of them is an obtuse angle, which means it's bigger than 90 degrees. And my reason for that would be my assumption. So I'm going to assume that it does have an obtuse angle. Well then, if I take my obtuse angle, angle A, the one I'm assuming is obtuse, and add it to my 90-degree angle, that's going to have to be bigger than 180 degrees, because if I take 90, something bigger than 90, and add 90 to it, that's going to be bigger than 180 degrees. So that's just addition. Okay, but I also know that all three of my angles have to add up to be 180, because that's the triangle sum theorem. So I'm going to say that, well, angle A plus angle B has to equal angle C. Okay, so hopefully you can already see what's happening here. I've got these two angles right here that are adding up to be bigger than 180 degrees. Well, it's supposed to take all three of them to equal 180. So I've already kind of got a contradiction here, though. So to finish this off, I'm going to solve and show that that's not possible. Okay, so I'm going to subtract angle C over. So A plus B equals 180 minus C. And then I'm going to substitute. So I'm going to take AB out of this, or out of this one, okay, because A plus B is this, so I'm going to take this and substitute it in place of this guy. So that'll be gone, and that gives me this new statement. 180 minus angle C is greater than 180. But if I simplify that, I'm getting that 0, so I'm basically, I'm subtracting 180 here, 180, and then I'm dividing both sides by negative. So I get 0 is bigger than angle C, which means there is no angle C. If there's no angle C, then I don't have a triangle, because a triangle means 3 angles. If angle C is less than 0, that means there's no angle there. So this is a contradiction. This contradicts the fact that I started with a triangle ABC. Because I don't have an angle C, so that means my given information can't possibly be true. So if I've assumed the opposite, and it turns out that can't possibly work, that means that this has to be true. If the opposite of it can't be true, then this has to be true. And that's how indirect proofs work. So I've got a couple more examples to go through. I mean, if you kind of get it, you can try some. But if you want some more examples, just keep going. Okay, so here's the next example. I'm given that angle 1 and angle 2 are supplementary. And I want to prove that M is parallel to N. Our direct proof, in our direct proof, we could prove this right away. Okay, our direct proof would go like this. We'd say angle 1 and angle 2 are supplementary. That's given. And then we would just say M is parallel to N by the consecutive interior converse. Okay, because these are consecutive interior angles, if they're supplementary, it guarantees that these are parallel. So that'd be our direct proof. Our indirect proof would go like this. We're going to assume that this is not true. Okay, so we're going to say M is not parallel to N. That's our assumption. Well, if M is not parallel to N, that means that they're going to meet somewhere. Okay, so I'm going to change my picture. It means that they're going to intersect somewhere. Because if they're not parallel, then they have to meet somewhere. So we're going to assume that they, okay. Because of that, we're going to have to say that, we'll add angle 3 in there. Angle 1 plus angle 2 plus angle 3 equals 180 degrees. Okay, that's our triangle sum theorem. But I already know that angle 1 plus angle 2 equals 180 degrees. Because that's given. Okay, that's, well, I guess that's actually the definition of supplementary. And then by substitution, I would have, so I'm going to take out 1 and 2 from here and put 180 in there. I would have 180 plus angle 3 equals 180. Okay, so that means, so that's just substitution. If I simplify, I would get that angle 3 equals 0 degrees by subtraction. Okay, so again, we can't have this angle 3. So this is contradicting our assumption. So this is a contradiction. Okay, so since I've shown that it's not possible for these to not be parallel with my given information, that means the only answer is they have to be parallel. So I've proved the opposite can't possibly be true. That proves that this has to be true. So let's do one more example. So if you want, you could pause and try this one on your own, and then come back and I'll finish it. So here we're given RU is an altitude, and RU bisects angle SRT. We want to prove that triangle RST is isosceles. So I'm going to assume the opposite is true. Okay, I'm going to assume that RST is not isosceles. Okay, then that's my assumption. So let's put our given information on here. So RU is an altitude. So if this is an altitude, I know that it's going to make a right angle here. Okay, so I'm going to say angle RUT and angle RUS are right. Okay, that's the definition of an altitude. RU bisects SRT, so that means that SRT, this big angle here, has been split into two congruent angles by RU. So I can say that angle SRU is congruent to angle TRU. That's the definition of bisect. Okay. Now, I can say that RU is congruent to RU. from reflexive. And then I've got angle side angle to say that these triangles are congruent. SRU is congruent to TRU. Angle side angle, which means that RS is congruent to RT, okay? Is there corresponding parts on the congruent triangles? So the corresponding parts of congruent triangles are congruent, which contradicts our assumption. Our assumption that it was RST is not isosceles, but I've just shown that it is isosceles. So that contradicts our assumption. So our assumption, which was the opposite of what we were trying to prove, can't possibly be true. So if it's not possible for it not to be isosceles, then the only option left is that it is isosceles. So that proves that RST is isosceles with this given information.